Good afternoon, friends. Now we are having a discussion on dimensional similitudes and dimensionless numbers in module number 4 of the subject fluid mechanics. Okay, what are similitudes? So the name itself says that it is the similarity between the model and its prototype in every respect. So before going for the actual structure of any component of a machine, so its model will be prepared. So the similarity between the model and the prototype, if they are equal, so then it is called as similitude. So the model and the prototype will have similar properties. So we have different types of similitudes. Geometrical similitudes, so similarity of dimensions. Kinematic similitudes, so similarity of motion. And dynamic similitudes, so it is similarity of forces acting on the model and the prototype. So forces acting in any moving fluid. So inertia force, so that is Fi. So it is the product of mass and acceleration of the flowing fluids, and this inertia force is acting in the direction opposite to the direction of acceleration. So inertia, so that is the state of rest. So naturally the inertia force is acting in the direction opposite to the direction of acceleration. Viscous force, Fv. So it is the product of shear stress tau due to viscosity and surface area of the flow. Because stress is equal to force by area, so force is the product of stress multiplied by the area. So shear stress tau, that is due to viscosity into surface area of the flow. Then gravitational force, Fg. So it is the product of mass and acceleration due to gravity. F is equal to mg. Then pressure force. So the product of pressure intensity and cross-sectional area of the flowing fluid. So pressure force is the product of pressure multiplied by the area. So surface tension force. So it is the product of surface tension multiplied by length of the surface of the flowing fluid. So here we are not considering the area of the container in which the fluid is flowing. So the product of surface tension multiplied by the length of the surface of the flowing fluid. Dimensionless numbers. So Reynolds number, the first one. So that is most important, which is deciding whether the flow is laminar or turbulent, as we discussed earlier. So Reynolds number is the ratio of inertia force by viscous force, Fy by Fv. So inertia force, so it is the product of mass into acceleration. So where mass is written as density into volume, because density is equal to mass by volume. So mass is density into volume into acceleration. So velocity by time taken, V by T. So just rearranging the terms, so we have density into volume. So volume by time. So this ratio we call it as discharge Q into velocity. So this velocity by time is discharge. So that is written as the product of A into V. Q is equal to A V into V. So now inertia force will be substituted as rho into A V square. Then viscous force. So it is shear stress multiplied by the area. So shear stress by Newton's law of viscosity will be written as mu into du by dy into A. So du, change in velocity. So we are writing V. So dy is nothing but the length L. So on simplifying, so we have Reynolds number as rho VL divided by mu. So when the flow is taking place in the pipe, instead of length L, we have the diameter D. So Reynolds number is given by rho Vd by mu. Then Faraday's number. So it is square root of inertia force by gravitational force. Just we are substituting the dimensions of individual forces. So inertia force is given as rho into A into V square. So rho AV square. Gravitational force F into M into G. So M mass, that is density into volume into G. Volume is written as L cube, L to the power of 3. So rho L cube by L cube into G. So now L cube, so that is written as area into length. So L square into L. So that is nothing but area into length L. So into G. Simplifying, we are getting Faraday's number as V divided by square root of Lg. Then Euler's number, so that is square root of inertia force by the pressure force. Inertia force is written as rho AV square. Pressure force is written as pressure into area. So area gets cancelled. So we have V and just rearranging the terms divided by square root of P by rho. So that is Euler's number. So then Weber's number. So it is the ratio of square root of inertia force by surface tension force. So surface tension as told. So it is the product of surface tension multiplied by length of the surface of the flowing fluid. Surface tension sigma into surface length L. So inertia force is written as rho AV square. So A is written as length square. So V square. Simplifying, we are getting Weber's number. Mass number M. So it is square root of inertia force by elastic force. So inertia force is rho AV square. Elastic force is elastic stress multiplied by area. Elastic stress is K into area written as L square. So area is written as L square here. They get cancelled L square, both numerator and denominator. We have mass number as V divided by square root of K by rho. Thank you friends.